Alright, so in this question, it's going to talk about the variation. So first of all, we have the gx is sum of two parts. When you see the keyword sum of two parts, you need to think about the k1, k2 stuffs. Remember, k1 something plus k2 something. So the first part is various as x, and the other part is various as x cubed. So when they just said various, which means it's directly various, so you just times the k with the x. So first of all, you can just write down the gx is equal to, because this is sum of two parts, so k1 something plus k2 something. And the first something just the x, and the second something is the x cubed. So if the question says that inversely, if we have the inversely, then it's going to be divided by x. But when they didn't say inversely explicitly, then it just times the x, okay? So for this part and the second one, the second sentence that we have is g negative 1 equal to 12, or we have g3 equal to 12 as well. So now we can say that g negative 1, which means you just replace all of the x by negative 1. So we change to negative 1 first, and then you just copy all the rest. Okay, and the g negative 1 should be equal to 12, so it's equal to 12. Then this is our first equation, but we can try to simplify this. So negative 1 times k1 giving you negative k1, and negative 1 to the power of 3. So negative times negative times negative, still giving you negative. So negative k2 is equal to 12. So this is going to be your first equation. And then for the second equation, we can consider the g3, isn't it? So g3 is equal to, you change the x becomes 3. So k1 times 3 plus k2 times 3 cubed equal to 12, and then now I have 3k1 plus 27k2 equal to 12. Then this is your second equation. Because this is actually a A2 question, the long question, you don't need to write the steps how you how you solve the simultaneous equation. You can just use the program 01. So program 01 to substitute numbers start with negative 1, negative 1, and 12. And then we have 3, 27, and 12. So we try to substitute in. So we have the k1 is equal to negative 14, and then k2 is equal to 2. But don't forget, the question is asking for gx, they're not asking about the k1 and k2. You still need to replace your k1 and k2 back to the gx. So I need to write down, so we have the gx is equal to negative 14x plus 2x cubed. What I have done is just replace the k1 by negative 14, replace the k2 by 2. So now we have for our part A, and for part B. So part B, they're asking gx equal to 0, is there any rational root? So first of all, it just claims that it's not the truth. You need to consider about it. So we consider the gx is equal to 0, but what is gx? Gx just replaced by negative 14x plus 2x cubed is equal to 0. So I make the power at the front, so make the x cubed to the front. So 2x cubed minus 14x equal to 0. Then we can try to take the common factor out. So both of the numbers is even numbers, we can take out the 2, and then x cubed and x, we both have the x as well. So we can take out the 2x, then we open the bracket, copy from the left. So 2x cubed, take out the 2x, the 2 is gone, x cubed, take out the x, we have is x squared. And then 14 take out by 2 is going to be 7, and the x is gone. Then now you need to remember when I have two things times together equal to 0, then we can say that the 2x is equal to 0, or x squared minus 7 equal to 0. Then when 2 times something equal to 0, the something must be equal to 0, or we have x squared equal to 7. Then I don't want the square, I move it to the right hand side, becomes plus or minus square root 7. So actually, square root 7 is the irrational root because we can't change it, becomes to a fraction. The fraction with the denominator and the numerator both integer. So we actually has irrational roots. It's not all of them is rational, but the question just asking, is there any irrational root? So we actually agree. So agree, because square root 7 is irrational. Okay, so that's for part